Hi, this is OrgoChemSimplified, and here we're doing a mechanism problem involving alcohols. So the first thing you want to do when you approach a mechanism problem is, what kind of reagents do I have? First, I want to look at this ArSO3H. The H at the end should be very significant in terms of, you want to think of it as an acid. Now, how do we know that? Well, normally we have H2SO4. When do we see sulfur? We see sulfur as a nucleophile. Clearly that's not the case here. The other time we see sulfur is as a central atom for an acid, and that's probably what we have there. So instead of looking at ArSO3H, what we can actually do is just call it H+. So it's just H+. Alright, so if we have an acid, we need a base, right? And oxygen is the most electronegative atom on our starting material. Right. So the next question is, which oxygen is going to be most basic? And it's probably this one on the end, because we know alcohols are more basic than ethers. Okay, so we have this lone pair here. It's going to grab that proton, and it's going to become water, right? So let's draw that out. Okay. Now that we have this, what do we know about water? Well, water, good leaving group or bad leaving group? Water is a really good leaving group, right? So it's probably going to leave. But that's going to leave us with a primary carbocation. So let's draw that out. So water leaves, we only have this extra carbon here. Now let's think about this. Is this stable? No. Primary carbocations are never stable. They hardly ever exist for a long period of time. Right? So we need a source of electrons to go to that positive charge. Well, we could have this O, but then when we get 3-ring structures. But what do we know about carbocations? They rearrange. Right? And the most stable ring configuration is 6, like the one we have here. So the closest pair of electrons that we can move there is the bond between the O and this carbon. So let's take that pair of electrons and let's move it there. What does that leave us with? Well, we have a 6-membered ring, right? And the positive charge is not here anymore, right? We were taking the electrons from this carbon, and we were giving it to that carbon. We were taking the electrons from this carbon and giving it to this carbon, right? So when you take the electrons from the carbon, you're going to generate the positive charge. Okay. Now we have two choices. Obviously, it's going to be elimination, because there's no nucleophile. There's no nucleophile to attack that positive charge. So it's going to have to be an elimination, which means one of these protons is going to be acidic. Now, which one is the most acidic? Well, here you would argue this in terms of electron pull. This carbon has a carbon next to it, so these are equally shared. This is very stable, and therefore this hydrogen is pretty stable, right? But here we have an oxygen, right? So what's oxygen going to do? It's going to pull electron density from that carbon. The carbon is going to want to make up for it by grabbing electrons. And where can it grab electrons from? This hydrogen. If you give the hydrogen off as an acid, it can grab these electrons and give it to that positive charge. So that's what we're going to do. And probably the most basic thing we have here is water. Water has a lone charge, a lone pair, sorry. It's going to pull that proton off, and this electron, these electrons are going to go and form the bond. Right? And that's going to give us our product. And this water came from this step. So as you can see, you don't really need to know the mechanism right away. All you have to do is work through it. Work through the steps and see, does this step make sense? And if it doesn't make sense, go back and keep trying to find steps that make sense. Find what starting materials you have. How are they going to interact based on what kind of reactants they have? And then once you know how they're going to interact, like this first proton step, everything is based off it. And everything is based off, I have these choices, but which choice is going to give me the most stable molecule or intermediate? And you keep following these steps, making the most stable intermediate until you arrive at the final answer. And that's how you approach any mechanism problem. So hopefully that helped you kind of figure out how to work through problems. And if you like this video, please comment. And I will try to make more. Please ask questions if you want. And thanks for watching.